Okay, in 6.2, we are going to talk about the properties of a parallelogram. A parallelogram is a quadrilateral. It's a quadrilateral that has two sides that are parallel, and these sides are parallel also. So this guy and this guy is parallel. This guy and this guy are parallel. And you're going to be so you're going to have a quadrilateral formed here. Okay. So this is a parallelogram. Okay, this is a parallelogram. So you have these sides are parallel, these sides are parallel. So in this type of situation, we find that this guy, so if you have A, B, C, D, AB and DC are congruent. So this guy and this guy are the same length. AD and BC are also congruent. So this guy and this guy are the same length. Okay? So two lines that are parallel meet together like that. So if you form a parallelogram, this length and this length are the same. This length and this length are the same. Also, this angle and this angle are the same. This angle and this angle are the same. Okay? All right. Also, these two angles, when added together, what are they going to be?
degrees.
180 degrees. They are going to be supplementary to each other because this is a parallel line, which means that these two are what? These are the same side interior angles, right? So they're going to be, if they're going to be 180, when you add together, they're going to be 180 degrees. Okay, all right, good. Last but not least, the two diagonals bisect each other. In other words, this length and this length are the same. This length and this length are the same, okay? So they bisect each other. This length and this length are the same. This length and this length are going to be the same, okay? That in a nutshell is what we're going to learn, is what we're going to learn today, okay? That's what we learned. So the parallelogram, again, to summarize, two parallel lines meet together. This length and this length is the same. This length and this length is the same. These two angles are the same. These two angles are the same. They are supplementary to each other, just as these two would be supplementary to each other. And the diagonals bisect each other such that this length and this length are the same. This length and this length are the same. Okay? All right. So, middle of page 403, theorem 6.2-1. If a quadrilateral is a parallelogram, then its opposite sides are congruent. Opposite sides are congruent, right? We talked about that. Flip the page. 6.2-2. Quadrilateral is parallelogram. The opposite angles are congruent. Opposite angles are the same. Opposite angles are the same. 4.2-3. The parallelogram, then the consecutive angles are supplementary. These two are supplementary. These two are supplementary. And actually, these two are supplementary and these two are supplementary also. Okay? 6.2-4. If a quadrilateral is a parallelogram, then the diagonals bisect each other. Again, this and this are the same. This and this length are the same. Okay? Now let's see if we can do some examples using this. Example 1. The parallelogram shaped by linkage, race car. Find each measure. Okay, so we are given a parallelogram that looks like this. This is what the parallelogram looks like, and it's going to be PQRS, PQRS. We have T in the middle, looks like. QR is 48, so this length is 48. RT is 30, RT here is 30. And QPS is 70 degrees. QPS, this guy here is 73 degrees. Find each measure. Find PS. They want us to find PS. PS is down here. Since these two are congruent, this has to be 48. Next one is they want to find PQR. PQR, so it's going to be this guy over here, right? This guy and this two angle have to be supplementary. So this guy PQR is going to be 180 minus 73. 107. PT, now they want us to find PT. PT is this guy, which is the same as this guy because it's a diagonal and it bisects each other. So PT would be 30. Okay, pretty simple. It's example number 1. And let's do example number 2. Example number 2, we have ABCD. ABCD. Oof, we have 5x plus 19, 10y minus 1, 6y plus 5, and then we have 7x. Okay, find the measure AD. We want to know AD. AD is this guy. It has to be the same with this guy, right? So we know that 7x is equal to 5x plus 19. Okay, so I move this guy over. So I subtract 5x from both sides. I get 2x equal to 19. X is equal to 9.5. So AD is going to be 7 times x, which is 9.6. And if I do that, I get, it's 9.5, I'm sorry. 9.5. Where did I get 9.6? 9.5? 9.5, I get 66.5. Okay? Angle B, they want us to know, they want to know what angle B is, but these two are going to add to 180, so I get 6y plus 5 plus 10y minus 1 is equal to 180. Gather the y's, I get 16y plus 4, 180. I move the 4 over, I get 16y is equal to 176. Y is going to be this divided by 16, 11. But the question is not to find, they didn't ask for y. What did they ask for? They asked for the angle B. And angle B is 6y plus 5. So 6y plus 5. 6 times 11 plus 5, 66 plus 5 is 71. So your answer is going to be 71 degrees, right? Okay. All right, let's do example number 3 next. Example number 3. The 3 vertices, find the coordinates of vertex C. Okay? One, -2, 1, -2. And that was going to be what? A, that's A. And then we have B, which is -2, 3, -2, 3. And then we have C, which is D, which is 5 and -1. 5 and -1. D, 5 and -1. So I have something that looks like this, this. So obviously it's going to be up here. I'm going to go down here, right? So I need to find this guy here, which is C. So that's what I need to find, right? So how would you find that? You need to find their parallel. So this slope and this slope would be the same, correct? So I can do that. What else can I do? I know that this slope and this slope are the same too, right? So if I call this guy X and Y, since I don't know what it is, let's find the slopes and compare the slopes. So let's do these two slopes first, right? So the slope of this guy is going to be what? Slope of this guy is going to be -1 minus -2 over 5 minus 1. It's going to be the same as this slope, which is going to be x minus -2 over y minus 3. Okay, so I have that guy. So let's figure this guy out first. Okay, so I have -1. It's going to be +2, so it's going to be 1 over 4 x plus 2 over y minus 3. So I can cross multiply, they should be the same. 4x plus 2 is equal to y minus 3. So we get 4x plus 8 is y minus 3. So I'm going to go ahead, well, let's leave that as it is. So I compared these two. Now let's go and compare these two. So the slope here is going to be -2 minus 3 over 1 minus -2. So that slope has to be the same as this slope. So it's going to be -1 minus y, 5 minus x, -5. This would be plus, this would be 3. This will go to -y minus 1. 5 minus x, we'll cross multiply again. -5, 5 minus x is equal to 3 times -1, -y. -25 plus 5x is going to equal to -3 minus 3y. I'm going to move the -25 over here. It's going to be -3y. If I move it over, I get plus 22. So I have 2 unknowns and I have 2 equations. So I need to solve this system of equations, right? Over here, let's go ahead and go one step further. I'm going to move the 3 over here. So I'm going to get 4x plus 11 is equal to y. Okay, so let's go and see if we can go back to algebra and pre-algebra and see if we remember how to solve system of equations here, right? So I have 4x plus 11 is equal to y. I have 5x is equal to negative 3y plus 22. Okay? So how am I going to solve this? What are the methods that we learned in solving system of equations? Let me kind of clean this up, see if you can, this will maybe bring your memories back. So I'm going to move the y over here and the 11 over here. So I'm going to have 4x minus y is negative 11. I'm going to have 5x, move the 3y over here, is going to be plus 3y, 22. How do I solve this? Can everybody tell me what the two methods of solving system of equations were? Nobody?
Elimination.
Elimination is one, yes. Good work. One is elimination. What's the other one? The other one was substitution, right? So on this one, since we have the y bare by itself, right? I can just simply put this guy underneath here and solve it. So that's a substitution method, and that would be the preferred method here, right? So I have 5x is equal to negative 3, where y is, I'm going to put 4x plus 11 plus 22. 5x is equal to negative 12x minus 33 plus 22. Oops. X. This does not look right. So I screwed up somewhere. I must have screwed up somewhere. Where did I screw up? I erased everything. So the answers are supposed to be 2 and 4. The answers will be 2 and 4. What did I screw up? 4, 2, 10. That one works. So I did everything okay there. What did I do wrong here? 8. Huh. Yeah, I must have done something wrong here. So I did this part right. I did that part wrong. Okay, so the answer is 2 and 4 when you go. I'm not going to go through the whole thing. I'm not going to find out where I screwed up. I must have missed something there, okay? The book actually does it in a more concise method, okay? And the way they do that, and this is a way that I did not want to do, you can do it this way, okay? It's an easier way, but I did want to go over substitution and elimination. The way the book does this is that what they do is they go from here to here, the rise and the run has to be the same as the rise and the run from here to here, okay? So this guy here was, what was this? 1, negative 2, and this guy was 5 and negative 1, and this guy over here was negative 2 and 3, okay? So if we go from here to here, the run was, I went from 1 to 5. So the run was 4. So I'm going to go 4 from here to here. So if I go 4 from negative 2, it has to be plus 2, right? So it's going to be plus 2. So that's where you get the 2 from. And then the rise, once you go over here, the rise went from negative 2 up to negative 1. So that's actually down here. Okay. So I went from negative 2 to 1, negative 1. So I went up 1. So I'm going to go from 3 to up 1. So it's going to be 4. Okay. So that's what they did there. Okay. Do you see that? Everybody see that? How I went from the same run, which is from 1 to 5, which is 4. So I go 4 from here to 4, which is 2. And then I go up 1 from -2 to -1. So I go up 1 from 3, makes it 4, 2 and 4. Okay, all right. And last but not least, let's do example number 4. Example number 4. We have a parallelogram. A, B, C, D, and then we have the 2 diagonals and E in the middle. Write a 2-column proof. Given that it's a parallelogram, prove that angle BAD and DCB are the same. Angle BAD and which angle? DCB are the same. So we need to prove that that's the same. Okay? And also we want to prove that ABC, this guy here, is the same as that guy. Okay? So I'm not going to go to the 2-column proof, but let's kind of just think it through. How would we prove that? How would we prove that these angles are the same? If I can somehow prove that triangle, this triangle, and this triangle are congruent, then I can say that these 2 angles are the same. So let's see if we can try to prove that ABD and triangle CABD, CDB, CDB. Let's see if we can do that. Because if this is true, then I can say that this angle and this angle are the same. Because ABAD, right? It's not ABC. ABD, CDB. Okay, yeah. So then I can say that angle BAD would be the same as angle DCB, right? Okay, yeah. So let's see if we can prove that. So we can prove that by using what? This line is the same, right? This line is the same. But I also know, since it's a parallelogram, this guy and this guy are the same, right? I can also prove that this angle and this angle are the same. Can anybody tell me why those are the same? These are parallel, and I'm cutting it through this. So these 2 angles are called what? They are alternate interior angles, and therefore they are the same, right? So this length and this length are the same. They share this length. So from the congruent theorem of side angle side, these 2 triangles are congruent. Therefore, this angle and this angle must be the same. Okay? All right. So that's that. Looks like we're done. Okay, so your homework for this section is okay, so let's go ahead and get started working on that.